Hi guys, today we're going to be talking about L'Hopital's rule, as you can see, which is chapter 8.7 in your textbook. And this whole chapter has to do with using the initial indeterminate forms as a rule to abide by, in which you solve the limits of functions at infinity. So to begin L'Hopital's rule in the chapter, we have to talk about indeterminate forms. So let me spell that out for you. Indeterminate forms, which are essentially the forms in which you would have one function over the other, so like f of x over g of x, and the limit as x goes to infinity ends up being a fraction that is either 0 over 0 or infinity over infinity, which is positive, negative. Using these forms, you can begin with L'Hopital's rule, which uses the principle of saying that the quotient of any function of f of x over another function of g of x, so they have to look like two separate functions, and we'll find that out in the examples. So the limit as x goes to infinity, or sorry, as x goes to c of these functions, it doesn't have to be infinity, my bad. This is his rule. The limit of these as x goes to c is equal to the limit as x goes to that same value of the derivative of the f of the first function over the derivative of the function in the denominator. And this is only when this rule is only true for the indeterminate forms that we just talked about, which is 0 over 0 and infinity over infinity. And you can use the rule incorrectly by applying the quotient rule, which is what you shouldn't do, because in L'Hopital's rule, the function f of x over g of x are seen as two separate entities. So you are really just, whenever you're doing a problem, you take the limit as x goes to c of f of x over the limit as x goes to c of g of x, which equals the limit as x goes to c of the derivative of the first function, and so on. And by doing this and looking at it that way, instead of mistakenly applying the quotient rule as learned earlier, you can use L'Hopital's rule to actually find the limit instead of taking an incorrect path. So now let's look at some also on the versatility of the rule itself. It doesn't just go for limits that are two-sided, it also goes for one-sided limits as well. So that's just as simple as saying the limit as x goes to c from the left side, per se, of f of x over g of x would just equal the limit as x goes to c from the left side of the derivative of the numerator function and the derivative of the denominator function. So now let's move on to some examples. So first we're going to start with the indeterminate form of infinity over infinity in this example. So let's say we have the limit. Let's get a new one. The limit as x goes to infinity of 5x squared, 4x squared minus 2x plus 3 over 2x squared minus 7. So first off, we're going to look at how we got the indeterminate form of infinity over infinity so we can classify it that way. So as we take the limit as x goes to infinity of the numerator, we get we have a leading coefficient or leading exponent of 2. So the function's going to be going to infinity increasingly, but the ratio of the exponents right here of 2 to 2, the ratio, so the exponent in the numerator equals the exponent in the denominator, so they both approach the same value of infinity over infinity, and so that's not what we want, but we're marking that as indeterminate. And so to continue, now we're going to use L'Hopital's rule. This is just how the steps go. So we are rewriting the function after we have just proven that it's the indeterminate form of infinity over infinity, which is the first step before using L'Hopital's rule. So now we're going to use L'Hopital's rule. So we have already stated the limit. So we're going to rewrite the limit as x goes to infinity. But instead, we're going to now using L'Hopital's rule. So this is the first function. So the derivative of this function would be 8x minus 2, and the derivative of the function in the denominator would be 4x, and so the limit as x goes to infinity of these two functions as a whole, actually. So we're going to see that the ratio of the exponents, so this is just x to the 1 basically, is the same. So we're only looking at the leading coefficients of 8 over 4. So it equals the limit as x goes to infinity equals that 8 over 4. This 2 doesn't matter, which can be simplified down to just 2. So using L'Hopital's rule, we have figured out that instead of the limit being this indeterminate form of infinity over infinity, that it is actually the limit of this quotient function overall is 2. So now we're going to look at the indeterminate form example for 0 over 0. So let's say we have a function with its limit as x goes to 0 of sine of 6x over 4x. So we know that the limit as sine of 6 times 0, which is just 0, so sine of 0 is 0. So we know that if we take the limit of the numerator, it's going to equal 0. And for the denominator, which is 4 times 0, still equals 0. And by doing so, we have just proven that we can use L'Hopital's because it has come out to an indeterminate form of 0 over 0 if we just take the limit normally. So now using L'Hopital's rule after that initial step, we can say that rewriting the function, limit as x goes to 0 of sine of 6x over 4x is equal to the limit as x goes to 0 of the derivative of sine x would be, using chain rule, which we learned already, would be cosine of 6x. So the subject doesn't change, which is what it's cosine of. And so evaluating the derivative of 6x using the chain rule, we get just 6 as a multiple of cosine. And then the derivative of 4x is just 4. So we could simplify this real quick. So limit as this is, it turns into the limit as x goes to 0 of 3 cosine of 6x over 2. So we can take this out of the function, so it just is 3/2 times cosine of 6x, and the limit as x goes to 0 of that, which we know that the limit as x goes to 0 of cosine of 0, so 3/2 times, so 3/2 times cosine of 0 is going to equal 3/2 times 1, which is just 3/2. So using L'Hopital's rule, as I've said before, we have proved that this function of sine, the limit as x goes to 0 of this function sine of 6x over 4x is not actually 0 over 0 as the indeterminate form is, but it's actually 3/2, all done by using L'Hopital's rule, which we have just learned. Alright guys, that's it. Remember to consult your textbook and ask your teacher if you have any questions. Bon voyage!